Welcome to Geosynthetica's GeoTalk podcast, where we discuss geosynthetics and affiliated issues in civil and geotechnical engineering. I'm Chris Kelsey, editor of Geosynthetica.net. The field of geosynthetics has often been defined by how these materials can improve the performance and economics of a particular site or application. One of the ways that geosynthetics achieve these goals is through rigorous testing to ensure proper selection of a material and proper design. However, engineering approaches are often driven by a market's level of infrastructure development and regulatory readiness. This can lead to some stark differences in how geosynthetics or other materials are qualified for acceptance on a site or in an engineering sector. I talked with Kent von Maubeuge about this with respect to how puncture protection is approached for landfill lining systems around the world. My guest today is Kent von Maubeuge from NAUE. It's an international geosynthetics manufacturer and engineering services provider. Kent has been involved with the geosynthetics industry for about 25 years. He serves a chairmanship on a subcommittee of ASTM on GCLs. He serves a chairmanship on a committee with ISO. He is the director of technical affairs, or he is a director of technical affairs, marketing, and product management with NAUE. And I want to talk to him about puncture protection, because there's a bit of a difference between how we look at puncture protection from the perspective in the U.S. versus, say, a European perspective. And this has implications for how we understand how to design for projects. Kent, what are some of the differences that you find between U.S. standards and then European standards?
Thank you, Chris. Yes, there's a severe difference in the two methods, how they approach this topic on puncture protection. If we're talking puncture protection now, we're focusing on landfills. For example, in the base seal of a landfill, where you have a composite lining system or a double line system, you have a geomembrane, and over the geomembrane you have a leachate collection system. The leachate collection system is not a geosynthetic in this case, it's granular material. And to avoid that granular material penetrates into the geomembrane and I don't want to say destroys it, but causes at the beginning maybe some deformation, and in long term some puncturing, which then would automatically lead to permeation and leachate going into the subgrade.
Yes.
You have to put a cushion, as we call it, or a protection layer, protection geotextile in between. In the past, before geosynthetics existed and where geomembrane started, you used a sand layer for that. But to place 5 or 10 centimeters sand on top of a geomembrane, sometimes maybe the equipment will damage the geomembrane more. Mm-hmm. So we moved over in the time to use geosynthetics like nonwoven materials, needle punch nonwovens. The American approach is basically done on a theoretical basis. So what they do is they take a test method, an ASTM test method. In that pressure cell, there are truncated cones there. You put your lining system in there, put a pressure on it, and measure when you have a hole in the system. So basically you're measuring the tensile strength of the membrane or the puncture resistance of that system. But the situation you have then is you have a hole in there, and then you back calculate and try to figure out what is the mass per unit area a geotextile should have. And if you look at the designs we have and what's used in the US, you're using a 500 gram per square meter nonwoven material to protect against material which is 3/4 of an inch up to 2 inches in thickness, so basically 16 centimeters to nearly 50 millimeters in diameter. And if you just understand that if that protection layer is around about only 5 millimeters in thickness, it's very, very thin.
Yeah.
So it's a design based on numbers with no real background. I'll come to the problems a bit later then. The European approach, mainly developed in Germany, is that you take the realistic conditions from site. You take a rubber...
Is this a site-by-site basis, or is this a typical site?
That's a very good question. It's a site-by-site approach, and it's not an index test.
Okay.
So you take, the only difference is you don't take a clay material on the bottom, because installing a clay material in a cylinder, compacting it, moisture content, you can get a different deformation of that material. So you take, that's the only non-natural material from site. You take a rubber foam on the bottom side to duplicate the clay liner on the bottom. And then you put a lead plate, a geomembrane, the protection layer, and the gravel material you're going to use on site in that cylinder, and you apply a load on it. Now, this load is not just a specific load. The BAM, which is the Federal Testing Association in Germany, which is responsible for landfill design, is an independent organization, or it's an authority organization. They did over years in the 90s PhDs on all these topics I'm talking about. So it's not like just one or two tests, and then you say this is going to be the result. And then you calculate the load. For example, in a 50-meter landfill, you would have 50 meters times the density of the weight, and then you have the regular load. You then multiply this with a safety factor of 1.5, and you run the test now under 40 degrees centigrade for 1,000 hours.
Okay.
That's quite a long time.
Yeah, that's
they also
found
test. Correlation factors. You can run the test at 20 degrees C and only for 100 hours, but then you have to multiply the load by another 2.25 safety factor. And also those numbers are not just taken out from the moon. They are from PhD studies and doctorate works over the years. And then you measure that. Now comes the big difference, and now is what we're looking at, where you have the issue, the difference between many countries and Europe, especially Germany. You now measure the deformation of the geomembrane in that zinc lead, which is under the geomembrane.
Yeah.
And you're not allowed to have more deformation than 0.25%.
Okay.
Now, probably you're going to ask the question, why 0.25%? The reason is quite easy.
Yeah.
We know from polymer experts like Ian Peggs and Werner Müller from Germany that if a geomembrane has a deformation or elongation of more than 6%, it will undergo stress cracking, and over time then, lifetime of a landfill should be more than 100 years, it could start cracking and get damaged. So that is the number. Now, 6% is the number, the cutoff line. So engineers love safety factors, take a safety factor of 2, so you end up at 3%. And the 0.25% is basically, and that's maybe a bit difficult for me now to explain in this live pod, is that this 0.25% value represents the entire geomembrane and says that if you have 0.25% in the elongation, you will have single spots somewhere which can go up to 3%. So we do know from finite element calculations that an 0.25% deformation means that there are areas where you could have up to 3%. And the 3% value is our 50% from the 6%.
Do they look at deformation or a potential risk of deformation differently between an on a slope versus the base, or with the flat span of a panel, geomembrane panel, versus at a seam?
Very good question. I can tell you for sure, if it's a slope or if it's the base, it doesn't really matter, because the highest stress is in the base, because it goes vertical down, and the slope, it's divided up, and at the slope you have less stress the higher you go up. So it's not investigated, it's not differentiated between slope and the base. The seam one has not been investigated. That is definitely something which you have to look. However, we're looking at the deformation. So if you put a seam in there, you can measure the deformation in the seam as well.
Yeah.
I think the integrity of the seam is another topic.
Yeah.
So if you have deformation in a seam or next to the seam, it won't matter, only if the seam is not of the same purity or same quality as the geomembrane. So that's a different topic, but that's truly correct.
Now, your company has operations around the world, and you also have manufacturing and testing in Malaysia, for example, servicing the Asia market. Do you have different puncture protection standards you have to look at in Asia from what you do in Europe, from what you do in North America?
Absolutely. I mean, we are going after on those markets, and we have to follow what the market is asking for. So yes, we have different puncture protection considerations and different ways we approach it in other countries because those markets are not ready for that.
Yeah.
Yes, in Europe, there are several countries who are following that. Australia is following it, the same concept as well. We go to Malaysia, they understand what we're doing, but they are just not in the situation right now that they can go from a 500-gram geotextile to a 2,500 grams per square meter geotextile cost-wise. And therefore, they sometimes request higher deformation values. So they'll tolerate maybe 1% or 2%, and then therefore you're reducing the thickness of the geomembrane, the thickness of the geotextile. Yes, that happens. But that doesn't free us from what we want to do. We are constantly telling the world as much as possible why this is done, why we're doing this. I'm currently working with the BAM again and saying, come on, bring out another publication because it was published 20 years ago. Yeah. People don't read those literatures from 20 years ago.
Yeah.
So it gets lost. So you have to duplicate the information and do it again. And that's the reason why we're bringing out this information.
I guess one more thing I want to ask about this is there's a movement to do far more application-specific materials. Variations on a product, modifications to a product or enhancements to enable it to be more specific to a type of facility. Do you foresee that possibly instigating different puncture protection, standards, or will we see any variation in that market now?
Well, if you're looking at it in terms of the geomembrane, there are different geomembranes on the market. We know that. HDPE material seems to be the most chemical resistant material. The advantage is that it has the chemical, it's weldable. The disadvantage maybe, I don't want to call it disadvantage to other products, is obviously it has the stress cracking. Mm-hmm. But on the other side, I can't replace a material which is not chemical resistant just to save my stress cracking. Yeah. So HDPE is just considered as the material which you use for landfill lining systems, period. I don't think we have to discuss that. So I don't think there will be modifications there because you can't do much more. I think it's a market which has developed and the product that's the product how it looks like. If I now go into another term, and I never mentioned that in any of my past or present presentations, is can I do anything on the textile component? Well, we had in early days in Germany, we had a sand-filled mat, which is a bit difficult to install because they're heavy. Yeah. We had around about 25 kilograms per square meter sand in a system. But again, then you would lay panels, which is very complicated. It would be the best protection because you have the sand and the geotextile component together. We also had, in the early days, a concept where we put into the needle punch nonwoven on the top layer, the top third of the material, we put a scrim reinforcement inside, meaning that as soon as you get strength or stress from the top, it's divided into the scrim and doesn't go all the way down. That could be a possible development because in the end of the 90s we had projects where we saw in our testing that you could reduce the overall thickness of the nonwoven with that scrim inside, which makes it cost effective.
Yeah.
But production-wise, not everybody can do that.
Yeah. Yeah. I guess in the end, all of this work is to ensure that facilities go into operation in as ideal a condition as they can. And that's what's going to get us the real service life we expect.
Absolutely. I mean, a landfill with 50 meters waste on top of it, you can't excavate anymore. Mm-hmm. And if you have leachate going into the environment, you have an environmental disaster, environmental problem. I mean, we know that leachates are not inert. It's a chemical material. Yeah. It destroys our environment. So I think it's the responsibility of the engineers, of the specifiers. I mean, the manufacturers, of course, too, but I'm now pointing to the specifiers and to the EPAs that they understand that what they're doing right now, and I don't want to criticize what's happening in the U.S., but I mean, in 2014 in Berlin, there was a publication where they showed after installation that with a 500-gram geotextile protection layer on top of it, mm-hmm. that after the installation process, they had, I think, round about 50 to 100 holes and punctures in a small area of 35 square meters.
Wow.
And we're designing based on the calculation I mentioned at the beginning with 5 holes per hectare.
Yes.
I mean, there's work from Kerry Rowe now at his university, fantastic work. I mean, I read it's published in Geotextiles and Geomembranes. And in that publication, they took an aged geomembrane and put it into a puncture protection with the current 500 grams. And they found out that, again, under temperature, 85 to 75 degrees, high temperature, which you don't have a landfill, they calculated that there are 2.5 million holes per hectare due to stress cracking. Now, the good thing on that story is that if you go with the temperature down to 55 degrees, the holes were less. But still, mm-hmm. there were 35,000 holes per hectare in this age test. So we're talking around about maybe after 10, maybe after 20 years. And that is due to the stress cracking and due to the deformation of the geomembrane with wrong puncture protection textiles. So the 40 degrees values look better, but still, they found out the 3% value, which the BUM in the 90s already identified as the maximum value, mm-hmm. is the right value. Again, no misunderstanding for our listeners.
No.
Not the 3% deformation in the test. Because as I said earlier, just to repeat that, 0.25% deformation gives you single spots with 3%.
Yeah.
So the 3% value is pretty good.
Yeah. We're not impugning the quality of the lining systems. We're not suggesting massive environmental issues, but we're emphasizing the importance of puncture protection.
Well, see it this way. If you look at a landfill, and I don't have any numbers in my mind, but anybody can do that. How much does a complete base lining system cost?
Significant.
So we're talking about maybe, let's just put a rough number out there, just so that people have an idea what I'm talking about. I would guess you're talking maybe about $100 to $200 per square meter for a base lining system.
Okay.
Compacted clay, geonet, and gravel.
Yeah.
If you look at, or probably even much more, but if you look on what the extra cost is for increasing from 500 grams to 2,000 grams, we're only talking a few dollars.
Yeah.
And I don't think we should sacrifice, due to a few dollars, safety for long term for our children or for people living around the landfills.
Yeah.
I don't think that's something we should be even taking into account.
Yeah. But the facility owners wouldn't want that either.
Yeah. And if you live next to a landfill, and I live pretty close to a landfill, matter of fact, I would say it's the safest landfill in the world, not because it's built in Germany, but yes, the lining system is 2.5 millimeters geomembrane, HDP. The protection layer is 3,000 gram protection layer.
Yeah.
But the nice thing of this landfill, it has 30 meters natural clay underneath. So before anything gets...
it's pretty safe.
I think 500,000 years before anything can leach through that clay liner, or hundreds of thousands of years.
Yeah.
So, safest landfill in Germany.
Well, Kent von Maubeuge, I really appreciate you taking time and sharing your insights. and we'll keep improving our puncture protection strategies and make our landfills as safe, perhaps even as the one you live by.
Yes. Chris, thank you very much, and appreciate that you gave me the opportunity and time to talk with you.
Thank you,
Chris.
Kent. Kent is with NAUE Geosynthetics. Learn about the company's materials and engineering services at www.naue.com. We've also got links to puncture protection-related documents and stories and standards organizations in the podcast article for the broadcast. Visit www.geosynthetica.net and click on the Media tab. Thank you for listening.